Good afternoon. My name is Alexander Scharf, and I'm a PhD student at Luleå University of Technology in northern Sweden. My work focuses on wood densification, and today I would like to present you my research on hardness determination in surface-densified wood. In wood densification, solid wood is densified under certain temperature, moisture, and pressure conditions, resulting in densified wood. In surface densification, only one of the two pressure plates of the hot press are heated, resulting in a density peak on one side of the sample. Depending on the process parameters, different density profiles can be achieved. High peaks at the surface layer, wider peaks, or for example, peaks which start a little bit further in the core of the sample. The question is, which of these density profiles provides our wood with the best resistance for the intended application? In most research, hardness is the parameter used to answer this question. Here, a spherical indenture is forced into the wood and the material's resistance to the indentation is used to determine hardness. Since it's a ball-shaped indenter, the indentations can be very different and also different kind of failure can occur. Anyhow, the maximum indentation or indentation diameter is used to determine the hardness value, not regarding the kind of failure or the slope before. This means the indentation is depth dependent, where we test different things dependent on the indentation depth, and hence dependent on the density of our sample. When we test surface-densified wood, we add another depth-dependent variable, the density. Together with the depth-dependent indentation of the Brinell ball, we have two variables influencing each other, making comparison between the different surface-densified woods difficult. When testing hardness with a wedge-shaped or pyramid-shaped indenter, we have depth-independent indentation. These indentations are geometrically similar. To really answer the question, which of these methods is superior, we had to use multivariate statistics. We surface-densified solid wood at different process parameters, resulting in different density profiles of our samples. We then imported this density profile information into multivariate statistics. With the help of multivariate statistics, we can see how the density variables are related to the indentation depth. Does the surface layer have the biggest influence on the hardness measurement? And how far do we really have to densify into the core to achieve a high hardness reading? The relatively large coefficients in the surface layer of the sample indicate that high density in this area is related to a small indentation depth, while the variables further into the core of the sample have coefficients close to zero. Here, the density has a low impact on the indentation depth. The benefit of multivariate statistics is that a lot of variables can be included into the model. Here you see the density profile's influence on the development of the hardness curve. You see that the influence of the density profile changes during the hardness test. There's some area close to the surface on the left side, which always has a positive influence, while the area afterwards, a little bit further into the sample, sometimes has a positive influence on hardness, sometimes the influence is around zero, like now. This is information we get by using multivariate statistics connected to the density profiles, and it will be interesting to compare these results to the model of the wedge indentation depth test. So we are looking for differences and similarities between these two tests. Which of the tests takes more of the wood's properties into account, and how high is the repeatability? In the future, we have to analyze the wedge indentation data, make a multivariate model out of it, and compare it to the model of the Brinell testing. Hopefully, we can answer which of these two test methods should be used for surface-densified wood. There's also another question we should ask in the future. Should we really measure hardness, or are there other properties which are more important? I thank you very much for your attention, and I wish you a nice afternoon.